So welcome everybody to this latest video 162 Maths, and in this video we'll be going over what is meant by the rate of output. So before we get started, let me just give you the origins of this video. So I was asked to produce a video regarding the rate of output purely because this appears on the advanced information given about the GCSE exams of 2022 on the higher paper. Now, as a standalone topic, if you've never heard of rate of output, do not be surprised, because like I said, even as a maths teacher for however many years, I've never taught this topic as a standalone topic under the name of rate of output. So if you feel that by seeing this you feel a bit anxious and the fact that I've never been taught this or my maths teacher's never gone through it, it may just be covered in another sort of title. And I would say that why this is given to you on the advanced information is just to give you a bit of detail into what the question is going to be asking you on the exam. So it could be related to the rate of change, which again is covered in other videos, or something to do with the volume and looking at time, which again are standalone topics and not under the label of rate of output. So let me just quickly go through what each of these two aspects are. But like I said, this is no guarantee that this is going to be the question that comes up on the 2022 exam paper. But I would say, using all my wealth of experience, that it is most likely going to be one of these two things. So looking at the first one of rate of change. So this is basically where you are working out the gradient at a particular point. Now, personally speaking, if it was going to be this particular topic, I would suggest that AQA would have written this as a rate of change rather than a rate of output. But again, it could be classed as that. So I didn't want to sort of ignore it in the fact that that might not be the case. So to work out the rate of increase or decrease, or the rate of output, is basically just recognizing whether your gradient is positive or negative at a given point. So here, if I just label here this as my y-axis and this as my x-axis, so x is my input and y is your output, and that will always be the case. Now obviously, if you're not using x and y, you're using two other sets of units, then whatever is on that vertical axis will always be your output, and whatever is on your x-axis will always be your input. So if I then just draw a random curve, let's just do this here. And let's say I was asked to work out the rate of output at this point here, which I'm just going to call A. Now, what this is basically asking me to do is to find the gradient at point A. Now, again, this is covered in more detail in a video regarding rate of change, but let me just quickly go through how you would do that. So what you would do is you would draw a tangent, so a straight line that just touches that point at only one point only, and then you would work out the gradient of that blue line. So you turn it into a right angle triangle. Then using the units of the x and y axis, you would do the distance up over the distance across, recognizing that the line has got positive gradient, so then you will end up with a positive gradient value. If let's say my point, let's say another point, let me just go for a different color, let's go for this light blue, was at this point here, B. So again, I would draw a tangent at that line there. And again, there could be several answers. You just need to make sure that you do draw the line, and I then need to work out the gradient of this. So again, it's the distance up divided by distance across, using the scale on the x and y axis respectively, and then recognizing that this here is a negative gradient, so then you're expecting a negative answer. Now, if a question asked you, let me just get rid of all of this as best I can. Oh, let's just get rid of it all. If let's say I was asked to work out the gradient between 2 points, so let's just do another curve again, like that. And let's say point A is here and point B is here. Then what you're going to do is just going to draw a straight line from those 2 points and then draw your triangle, and again it's the distance up by the distance across. Now again, as you can see, the curve is way off that green diagonal line, so again there's going to be some discrepancy in that. But one thing that is for certain is that it's going to be a rate of decrease because you've got a negative gradient between the point of A and B. And again, like I said, if you have absolutely no idea what I'm talking about, then please do click on the video link, which I'll add in the description below, related to the rate of change. And there's also a video that goes through some common past exam questions. Now the next one is probably, I would say, linking to is going to be more applicable to the rate of output, which is basically working out the rate of a container either fills up or empties. Now, in terms of this, so what you're looking at, the rate of output is the volume of the shape divided by how much time you are taking. Now, from this, you are going to need to know and understand 3 elements of this, because like I said, what you could end up with is, and I'm going to go through some example questions, you'll see that some questions go on to where they ask you to work out the rate of output. Sometimes they may give you the rate of output and they're then asking how long does it take for the container or the shape to either empty or fill up at a particular point. And it could even be a particular point as well if it's a cuboid. So to be knowledgeable before attempting these types of questions, the first thing you need to know is to know how to work out the volume of 3D shapes. Now, obviously cuboids, triangular prisms, things like that are expected of you to know by heart, so there's no formula that's going to be given. However, formulas for hemispheres, spheres, cones and frustrums will always, and sort of pyramids, will always be given to you in your exam paper. So if you're not familiar with those formulas, do not worry, you'll be given those formulas. Now, if you are given a frustrum or a hemisphere, you're more likely to get the formula of a cone and the formula of a sphere, and then you then need to manipulate those formulas to then work out what that is going to be. Also, what is really important is that when you're working with rates, you want to make sure that your time units aren't mixed. And what I mean by that is that your time units are either in minutes only, so no seconds. So you're giving your, if it's, let's say 1.5 minutes, you're not writing it as 1 minute 30 seconds, you're writing it as 1.5 minutes. And you've got no mixture of units. So just make sure that you know how to either convert time elements to just hours, just minutes, or just seconds. But also, if you've got seconds, you need to know how to convert it to minutes, how to convert that into hours. So just be wary of that. And that covers time unit conversion. And then reverse questions, as I previously mentioned, is that sometimes they may tell you that you need to work out the volume of, let's just draw a quick cylinder of this, and you've got 15 and you've got 6 centimeters, and you might say that this container sort of empties at 0.6 liters per second. Okay, so which is pretty fast. So then the question might ask you is how long will it take for the container to be emptied? So that would be an example of a reverse question, because this here is your rate of output. So that there is your rate of output. And so and again, there are several questions that are available either on past exam questions or on the internet, or revision guides will cover those types of questions. But I would say that, as is mentioned in this format on the advanced information, it's more likely, again, if I had to put money on it, I'm not a gambling person, but if I was, I would say it's more likely to be the latter than it would be regarding the rate of change, only because if it was to do with gradients, it would probably have said so in the first place. Now, when trying to find past exam questions that related to finding the rate of output, I really did struggle to find such questions. A lot of questions that I found tend to be reverse questions, which gave you the rate of output, and you then had to work out the time needed. So again, what I've done here is just made up a question which allows us to kind of practice reading the question carefully, what things to look out for, but also to find that rate of output. So in this question it says, when the following container is filled with water, it takes 75 seconds to empty. Find the rate of output in litres per minute, and we've been told that 1000 centimetre cubed equals 1 litre. Now there's a lot of conversions based on this question, and if you were given this question in the exam, I would say it'd be worth probably at least 4 to 5 marks, because there is a fair bit of work that you need to do regarding units. So let's have a look at this. So the first thing when you notice is, and that you should notice, is that the rate of units that they want is in litres and in minutes. So I need to make sure that the volume is in litres. So the volume needs to be in litres and the time needs to be in minutes. Now looking at the dimensions of the cuboid, they're in centimeters, so I need to convert that into units. So the first thing I'm going to do is work out the volume of the cuboid. And how do I do that? Well, I just multiply all the units, or the dimensions which are in the same units by each other. So here, if I get the calculator out, and this is going to give me a pretty big number. So I've got 65 times 55 multiplied by 106, which can be multiplied any order, which gives me 378,950. So 378,950 centimeter cubed. So from this, what I then need to do is convert that into liters. So if I divide that by 1000, which is just moving the decimal point 3 places, so that gives me 378.95 liters. So that there is my volume. The next thing I then need to do is look at the time. So time, now 75 seconds is going to be 75 divided by 60, because there's 60 seconds in a minute. And if I type that into my calculator, which I'll get here, so 75 divided by 60 equals 5/4, which as a decimal is 1.25. So it's 1.25 minutes. So now that my units are converted, the next thing for me to do then is to work out the rate of output, which again, the formula is the volume divided by the time, and the volume is in liters and the time now is in minutes. So my rate of output is going to be in liters per minute. So it's going to be 378.95 divided by 1.25. And if I get the calculator back, we get 378.95 divided by 1.25 equals, and it comes out as 303.16. So 303.16, and that's liters per minute. And there we go. Now per just means a line, but again, if you want to write liters per minute, that's fine. Or if you want to write liters/minute, it means exactly the same. So now let's have a look at some past exam questions related to the rate of output. Now again, if you're wanting a copy of the questions, then all you need to do is just click on the link in the description below, and you can either have a go at those questions before watching this video, or have a go at the questions while watching this video. So let's get started. So looking at question 1, you can see that here we've got a hemisphere, which again is another topic on the advanced information for the GCSE paper of 2022. So here we're given the formula of the volume of sphere, and it says the container is a hemisphere with a radius of 30 centimeters, and sand fills the container at a rate of 4,000 centimeter cubed per minute. Does it take less than a quarter of an hour to fill the container? So let's just quickly highlight some of the important information that we then need. So this here is the volume of a sphere. So the volume of a hemisphere, which is going to be half, is going to be 4/3 pi r cubed, all divided by 2. It then says that this here is our rate of output. Let's just highlight that. And it then says that does it take less than a quarter of an hour? Now, a quarter of an hour is also known as 15 minutes. So I could then choose to see whether if I work in hours, it's going to be 0.25. And if I'm working in minutes, then it's going to be 15. So it's always important that you then decide, be a bit sort of confident in saying, right, okay, which units am I going to go for? So either minutes or hours, depending on which is entirely up to you. So let's go through how we actually work through these questions. Let me just get rid of that cursor. So then from this, and I'll do the answer here just so that we've got everything on the screen. So first of all, the first thing you want to do is work out the volume of the sphere, of the hemisphere. And so using this formula here, that's going to be 4/3 times pi times the radius, which is 30, cubed, all divided by 2. And that gives me an answer of 18,000 pi. And again, there is going to be a decimal equivalent, so it is what it is. Now I then need to divide that by 4,000. So from this, what I then get is if I divide that by 4,000, then what I'm doing is seeing how many minutes is that going to equal. So from that, what I can then do is do just that. And what I get is I should have an answer of about 14.1 minutes. Now let me just double check to make sure that is the case on my calculator. So here, if I set up my fraction and then set up the fraction again, I've got 4/3 times pi times 30 squared or cubed, and then scroll down to 2. So this gives me the volume, which is 18,000. I'm dividing that by 4,000 because that's the rate at which it empties or fills. So that's going to be 9.2 pi, and as a decimal that gives me 14.1, which is correct. So here, looking at this, does it take less than a quarter of an hour? Then yes, it takes less than 15 minutes. And there is my final answer. Now, it's really important that you do answer the question, because the question's actually, does it take less than a quarter of an hour to fill the container, not how long does it take. So it's really important that you do add this statement, as that could cost you 1 mark out of the potential 3 marks. Moving on to question 2, it says that Eva thinks she can save water by having a shower instead of a bath. Eva's shower uses 10.8 litres per minute, lasts for 8 minutes. Eva assumes that the water of her bath is in the shape of a cuboid, where 1000 centimetre cubed equals 1 litre. Using Eva's assumption, work out how many litres of water she saves by having a shower instead. Now, Eva's assumption is the fact that her bathtub is in the shape of a cuboid, nothing else. So it's just a case of looking at that. So let's first of all look at this in 2 steps. So the first thing I'm going to work out is the amount of water she needs when having a shower. So here I'm going to use this information here. So it's going to be 10.8 times 8, and that gives me an answer of 86.4 litres. So that's how much water she uses when she has a shower. So the next thing for me to then do is then work out how much water she uses if she has a bath. So for a bath, what I then need to do is work out the volume of a cuboid. So that's going to be 35 times 50 times 110. And that gives me an answer of 192500, and that's in litres. So then what I then need, in centimetre cubed rather. So what I then need to do is then convert this into litres, and I do that by using this conversion here. So if I divide by 1000, I'm going to get 192.5 litres. So as you can see, she's definitely using less water if she has a shower than if she has a bath. But the question is asking for us to see how much litres of water she saves. So I need to work out the difference between the 2 amounts. So the difference is therefore going to be 192.5 minus 86.4, and that gives me an answer of 106.1 litres. And there is my final answer. Then moving on to B, it says that A shows the water level before Eva gets in a bath, and B shows the cuboid in the empty bath. What does this tell you about the amount of water saved? Well, there's 2 possible popular answers you could give here. As you can see from the diagram, that the cuboid is a lot smaller, well, not a lot smaller, is smaller than the actual bathtub. So you can start by saying that. So the answer in part A is too small, was too low. And also another possible answer you could give is that the amount of water saved would be greater. So one stating that it's too low than what it should be, and the other is basically stating that it should be greater. So something along those lines would be enough to get that 1 single mark. Then moving on to question 3, it says that a water tank is a cylinder with a radius of 40 centimeters and a depth of 150. It is filled at a rate of 0.2 litres per second. 1 litre equals 1000 centimetre cubed. Does it take longer than an hour to fill the tank? So here it's giving me the rate of output, which is this, and I then need to work out what the time is. So the first thing I need to do is work out what the volume of the cylinder is going to be. Now to do that, I need to use the formula of pi r squared times h. So that's going to be pi times 40 squared times 150. And if I type that all into my calculator, I should end up with an answer. Let's actually just do that now. So here I've got shift pi times 40 squared times 150, and it gives me 240,000 pi. So that there is basically in centimetre cubed. So what I then need to do is convert this into litres. So convert into litres, and how do I do that? Well, I just simply divide by 1000. So then divided by 1000, that then becomes 240 pi litres. And then what I then need to do is divide that by 102, 0.2. So then here I've got 240 pi divided by 0.2, and let's just type that into my calculator, and that's per second. So actually let's go back. So for this, I'll show you a way that makes it easier now. Obviously if we're looking at 1 hour and we've got seconds, let's work in minutes to meet them halfway. So here 0.2 litres in 1 second, well then that means that in 60 seconds I'm going to get 60 lots of 0.2, which is going to be 60 times 0.2, which is 12. So I'm going to get 12 litres in 1 minute. And that's what I'm going to work with. So the rate is actually 12 litres per minute. So from this, I know this is the amount of litres. So now rather than dividing by 0.2, actually what I should have done is be dividing by 12. And if I type that all into my calculator, now again, the fact that I'm using pi is absolutely, you can use the exact values. It's not really a problem. I'm just doing that just to make it easy for me to type into my calculator rather than a long decimal number. It's also a little bit accurate because I'm using the exact values. So again, if I press equals, so what you could do is use 153.98. That would be absolutely fine. But if I divide that by 12, it gives me an answer of 20 pi, which is 62.8. And let me just write that down. So 62.8 minutes. So is that longer than 60 minutes? Yes. So does it take longer than 1 hour to fill? Yes, it does. And the reason for that is because 62.8 is greater than 60. And that would be enough to get you the full marks, which is 4. Moving on to question 4. So again, it looks very, very similar to the previous question. So let's just quickly go through this then. So for question 4, it says the diagram shows a cylinder with a radius of 6 centimeters and a height of 15 centimeters. Work out the volume of this shape. So again, using that V equals pi r squared times h. So the volume equals pi times 6 squared times 15. And again, just typing that into my calculator. So shift pi times 6 squared times 15 equals, and it comes up as 540 pi. Now, in this question, it doesn't actually tell me anything to do with rounding. So again, I can choose how I want to round it. So if I want to give my answer in terms of pi, that's absolutely fine. Or you could give it as a decimal if you don't feel comfortable leaving your answer as that. So if I just press shift, the SD button, it comes out with 1696. So 1696 point, and let me just get the decimal, 0.5. And that's to 1 decimal place. Part B then says that a tank contains 45,000 centimeter cubes of water. The tank leaks at 0.75 litres per minute. How long does it take for the tank to empty? So again, here we're not actually working with the rate of output. We're given the rate of output, which in this question is 0.75 litres per minute. So it's a case of reverse question. What I need to do is work out the time. So here, what we're looking at is rate of output equals volume over time. So therefore, if I want to work out time, it's going to be time equals volume over the rate of output. So this is the formula that I'm going to be using. So the first thing I need to do is work out what the volume is, which I know is 45,000, and it's litres per minute. How long does it take? So all I need to do here then is to work that out. So from this, all I need to do is then do 45,000 divided by 1,000, which equals 45. So then from this, so that's how many minutes it's going to take. And then from this, what I then need to do is, well, no, sorry, that's litres, not minutes. So then that's 45 litres. I then need to divide that by 0.75, and that comes up to an answer of 60 minutes. And there it is, my final answer for that one. Now for 4 marks, I would say that's pretty generous, I would say. But I would say you probably get maybe 2 marks for that, 1 mark for that, and then maybe 1 mark for your final answer. But again, very, very generous in that particular question. Looking at question 5, it says that an empty tank is in the shape of a cuboid as shown. The tank is filled with water at 1.25 litres per second. And then we've got 1 cubic meter equals 1,000 litres. Work out the time taken to fill the tank. So again, very, very similar to the previous question. So for this, what I've got to do is work out the volume, which is going to be 2 times 2 times 3, which is going to give me an answer of 12. So it's 12 meter cubed. Get rid of that equal sign there. I then need to convert that into litres, so using this. So I then multiply that by 1,000, and that then gives me 12,000 litres. Then I then need to divide that by the rate, so it's going to be 12,000 divided by 1.25, and that's going to give me how many seconds there are. So if you want to work with seconds, that's one thing to do, but I want to know how long it's going to take in hours and minutes. So I would scrap doing 1.25 and let's convert the time units. So 1.25 litres equals 1 second. So then 60 seconds or 1 minute. No idea what I'm writing there, so let me just get rid of that. So 60 seconds or 1 minute is going to be 1.25 times 60, and if I get my calculator back again, so 60 times 1.25, it equals 75, so that's 75 litres in a minute. And this is the units I'm then going to use. So if I then do 12,000 litres divided by 75, and that should give me 160 minutes. Then converting this, that's going to be 2 hours, which is 120 minutes with 40 minutes remaining, and that there is my final answer. Now if you did do it working with seconds, that's absolutely fine, but I would say this is probably the most logical way of doing it, most efficient way of doing it, and more chance of you getting the right answer. So that there is what we should have. Moving on to question 6, it says the diagram shows an empty cone with a radius of 1.5 meters and a height of 4 meters. Sand is poured into the cone at a rate of 0.2 meter cubed per minute. Work out the number of minutes it takes to fill the cone. So looking at this now, typically I would say this is more of an older question. So that there is 1.5 meters and this length here is 4 meters. Now, in terms of this, I don't need to worry about the units because the question is asking me how many minutes does it take, and my rate of output is in minutes in terms of the time units. So for this particular question, all I need to do is work out the volume of the cone. Now, the volume of a cone is going to be given to you. This is more of an older question. So the volume of a cone is 1/3 times pi times the radius squared times the height. So substituting those numbers in, what I get is I get 1/3 times pi times the radius, which is 1.5 squared, and times h, which is 4. And let me just make sure that does look like it. Yeah, it is. So then working it all out, what I get is I get 3 meters or 3 pi, and that's in meter cubed. So from this, what I then need to do is divide that by, and let me just work out what 3 pi actually is, which is 9.424 meter cubed, and that's been rounded to 3 decimal places, but I'm going to use the exact value. So then to work out the time, it's going to be the volume, which is 3 pi, divided by the rate, which is 0.2. And again, if I just type that into my calculator, so 3 pi divided by 0.2 equals 15 pi, or 47.1. So then the answer then is 47.1 minutes. And there we go. Do I need to work out what 1/10 of a minute is? No, because the question is asking me to work it out in minutes, so I can leave it as a decimal in minutes. So now let's move on to how you do question 7 involving gradients. So this question again looks at A and B. The reason why I say again, because this question was covered in the rate of change exam question video. So it says A and B are points on a curve, and it gives us the coordinates. And for part A, it says work out the instantaneous rate of change in y with respect to x at point A. In other words, what this question is asking me to do is to work out the gradient at A. So for this, what I need to do is to, as accurately as I can with a ruler, which again is going to be very, very difficult for me to do on the computer, but you want to draw a tangent, preferably that touches a point, which that one clearly didn't. That one's a little bit better. And then you then want to work out the gradient of that. Now, everyone's answer is going to be different, but as long as you are drawing that blue line, turning it into a right angle triangle, and then it's the distance across the distance up divided by the distance across. So here, the gradient is going to equal up over across. So looking at this, every little box represents 0.2. So counting the boxes, again, I've not drawn this accurately, so it's not going to give me actual answers. But here, this gives me, I would say, 4, 9, 10 boxes. So that's going to be 10 times 0.2 over, and how many boxes across is that? I would say it's going to be 4 and then another 3, so that's going to be 7. So 7 times 0.2, so that's going to be 20. No, it's not. It's going to be 2 divided by 1.4, and then whatever that is going to be. So again, your gradient values could be different, but make sure that you are drawing that straight line, the tangent at point A on your diagram, turning it into a triangle, and then working out the gradient accordingly. Now, where I've got 0.2 from is basically what one of these little small squares represents. So here I've got 5 squares equals 1, so one little square must equal 0.2 vertically, and the same applies to horizontally as well. Moving on to B, it says the average rate of change of y with respect to x between points A and B is worked out, which statement is true. So again, all it's asking is, what's the average rate of change from A to B? Well, A is here, B is there. If I draw a straight line going from those 2 points, you can see there I'm going to have a negative gradient. So then it's going to be negative. Question 8 says that the table shows the cost of hiring a concrete mixer for up to 5 days. And it says Eva hires the concrete mixer for 5 days. She says the rate is £14 per day because the cost of 1 day is £14. Is she correct? Give your reason for your answer. Well, the question is no, she's wrong. She's not correct. As after the first day, it's £10 per day. So something along those lines will be absolutely fine. You don't need to quote that word for word, but something along the lines of the fact that for 2 days would then therefore cost £28, in which it doesn't. So you can either give an example of where she's wrong, or you can state something similar to what I've written there. Moving on to question 9, so our last question, it says the diagram shows the position of a tap when when off and fully on. The tap is fully on when the angle of turn is 180 degrees. When fully on, the water flows out of the tap at 14 litres per minute. So let me just highlight that because that there is our rate. It says the rate of which the water flows out is directly proportional to the angle of the turn of the tap. The water flows into the tank with a capacity of 79.8, so that there is my volume. And the question saying, will it take less than 7.5 minutes to fill the tank? So for this, let's have a look at working this out. So for this, let's have a look at the rate of flow. Now to do this, it's all about proportion. So here I've got 135 degrees out of a maximum of 180. Now when it's 180, it's 14 litres. So if I times that by 14, that will give me the rate in which the water is pouring. So if I just get the calculator up again, so 135 divided by 180. Oh, what's going on there? Divided by 180 multiplied by 14, and it should be a number that's less than 14, in which it is. So that's going to therefore be 10.5 litres per minute. So from this, now I've got my rate and I've got my volume. So here the time equals the volume divided by the rate. So therefore it's going to be, and again in terms of the units, I want the answer of time in minutes, so I need to make sure that my rate is in minutes, which it is. So here it's going to be 79.8, and also for the volume as well, it's litres in the rate of flow, so it needs to be litres in the volume. So 79.8 divided by 10.5, and again if I type that into my calculator, which I will do now, 79.8 divided by 10.5, press equals, it comes up an answer as 7.6 minutes. So going back to the question, will it take less than 7.5 minutes? The answer is no, it won't, and the reason for that is because 7.6 is greater than 7.5, and they're both in minutes. Because another way of saying 7.5 is 7.5. And there we go, is our final answer.